Example 2, find a function given its derivative. Find all functions g such that g prime of x is equal to 4 sine of x plus 2x to the fifth minus the square root of x over x. Okay, so first thing we want to do is we want to be able to rewrite the given function as the following. So we're going to have g prime of x, which is going to equal 4 times the sine of x. And now we're going to share the denominator. So we have plus 2x to the fifth over x. And then that's going to be minus the square root of x, which is the same thing as x to the 1/2 over x. Okay, now let's go ahead and go a little further with that. So we have g prime of x, which is going to equal 4 times the sine of x, plus this is going to be 2x to the fifth divided by x is going to be x to the fourth. And this is 1/2 minus 1, so this is going to be x to the negative 1/2. Okay, so now we can use the formulas that we have in table 2. So let me go ahead and copy that in here. So here's our formulas in table 2. Okay, so we want to find the antiderivative of this function. So the antiderivative of this function, okay, we can call this capital G of x if we like. So we have 4. Now what is the antiderivative of the sine of x? We can see that the antiderivative of the sine of x is going to be negative cosine of x. Plus, what is the antiderivative of 2x to the fourth? Well, here, if you have x to the n, that means you're going to add 1 and then add 1 in the denominator. So the n is going to be 4. So this is going to be 2 times x to the 4 plus 1 over 4 plus 1. Okay, so therefore that's going to give us that result. And then minus, okay, this is going to give us x to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay, because again, we're using this antiderivative there. Okay, so now let's go ahead and simplify this a little further. So we get capital G of x, which is going to give us negative 4 times the cosine of x. And then this is going to be plus 2 times x to the fifth over 5. And this is going to be minus x to the negative 1/2 plus 1 is going to give us positive 1/2. And negative 1/2 plus 1 is going to give us positive 1/2. So therefore, what we're going to end up getting is the following. Well, remember that once we have our antiderivative, we always got to add the constant at the very end. Okay, so now let's clean this up just a little bit. So we have the antiderivative g of x, which is going to equal negative 4 times the cosine of x, plus this is going to be 2/5 times x to the fifth. And then this is going to be minus that 1/2, you're going to take the reciprocal, so it's going to be minus 2. And then x to the 1/2 is the same thing as the square root of x, and that's going to be plus c. And so therefore, this is going to be the antiderivative of that function. Okay, now in applications of calculus, it is very common to have a situation as in example 2, where it is required to find a function, given knowledge about its derivatives. An equation that involves the derivatives of a function is called a differential equation. These will be studied in some detail in Chapter 7. But for the present, we can solve some elementary differential equations. The general solution of a differential equation involves an arbitrary constant or constants as in example 2. However, there may be some extra conditions given that will determine the constants and therefore uniquely specify the solution.